An AI startup just raised $150 million at an $800 million valuation before shipping a single product.
Wait, $800 million pre-revenue? In this market? So we're breaking down what vLLM actually does, why speed matters more than models, and how this changes deployment costs.
By minute 4, you'll understand why inference is the new gold rush. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today we're diving into inference startup Inferact lands $150 million to commercialize vLLM.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about what might be the most important infrastructure story in AI right now. Inferact just landed $150 million to commercialize vLLM. And Alex, this isn't just another AI funding round. This is about solving what's become the hidden crisis in AI deployment.
Hidden crisis? That's a strong way to put it. What makes inference optimization such a big deal right now?
Here's the thing. Everyone's obsessed with training bigger and better models. GPT-4, Claude, Gemini, you name it. But once you've trained your trillion-parameter model, you hit this wall. Running these models in production at scale, that's where companies are bleeding money. We're talking about inference costs that can literally make or break whether an AI product is viable.
So we're saying companies have these amazing models but can't afford to actually use them.
Exactly. I was talking to a startup founder last week who told me their OpenAI bill went from $5,000 to $50,000 in a single month. And that's just using the API. Imagine if you're trying to self-host these models. The compute costs are astronomical. One company I know calculated that at their current growth rate, inference costs would exceed their entire revenue within 6 months.
But wait, isn't this what all the cloud providers are already working on? AWS has Bedrock, Google has Vertex AI.
Sure, but here's where it gets interesting. vLLM started as an open-source project out of UC Berkeley. It's not just another inference engine. It uses this technique called PagedAttention that fundamentally changes how we manage memory during inference. We're talking about 2 to 4x throughput improvements compared to standard implementations. And now, Inferact is taking this academic project and turning it into enterprise-grade infrastructure.
PagedAttention? That sounds like they're borrowing concepts from operating systems.
Exactly right. Just like how operating systems use virtual memory and paging to efficiently manage RAM, vLLM applies similar principles to GPU memory management for transformer models. The key insight is that attention mechanisms in transformers waste a ton of memory on padding and inefficient allocation. vLLM treats the key value cache like virtual memory pages.
So they're essentially solving a memory fragmentation problem.
That's a great way to think about it. Traditional inference engines allocate contiguous memory for each sequence, which leads to massive waste. vLLM breaks everything into fixed size blocks and manages them dynamically. This means you can serve way more concurrent requests on the same hardware. For companies running inference at scale, this isn't just an optimization. It's the difference between a sustainable business model and bankruptcy.
The $150 million funding round, though we should note that's unverified, suggests investors see this as critical infrastructure. But I'm wondering about the tension between the open source project and the commercial venture.
That's the elephant in the room, isn't it? vLLM has this vibrant open source community, and now there's a venture-backed company built on top of it. We've seen this movie before with Docker, Elastic, MongoDB. Sometimes it works out great. Sometimes the community feels betrayed. The key question is, what value is Inferact adding beyond the open source project?
And what's their moat? If the core technology is open source, what stops AWS or Google from just implementing it themselves?
Coming up, we'll dig into exactly how they're planning to build a defensible business around open source technology and what this means for the broader AI infrastructure landscape. Plus, we'll look at some real benchmarks that show just how dramatic these performance improvements can be. So let's get into the technical meat of what makes vLLM so special. The paged attention algorithm is genuinely clever. In traditional transformer inference, when you're generating tokens, you need to store these key value pairs for the attention mechanism.
The naive approach allocates a fixed chunk of memory for the maximum sequence length.
Exactly. And it gets worse with batching. Say you're processing 10 requests simultaneously. One might be 100 tokens, another 1,500, but you have to allocate for the worst case for all of them. vLLM says, forget that. Let's allocate memory in small blocks, typically 16 or 32 tokens, and build a lookup table to map logical positions to physical memory locations.
That's elegant. So you get much better memory utilization, which means you can fit more requests in the same GPU memory, which means higher throughput.
The benchmarks are pretty stunning. On an A100 GPU serving Llama 13B, vLLM achieves about 14x higher throughput than Hugging Face's text generation inference. We're talking about going from 20 requests per second to 280 requests per second on the same hardware. For a company spending millions on GPU infrastructure, that's transformative.
Those numbers sound almost too good. What's the catch?
Good instinct. There are trade-offs. First, implementing paged attention adds complexity. You need sophisticated memory management, which means more things can go wrong. Second, there's a slight latency overhead for the memory mapping. We're talking microseconds, but for real-time applications, every microsecond counts. Third, and this is crucial, not all models benefit equally. The gains are most dramatic for models with long context windows and variable length inputs.
What about the business model? How does Inferact plan to make money when the core technology is open source?
This is where it gets interesting. From what we can piece together, they're following the classic open source commercialization playbook. The open source vLLM gives you the core engine, but enterprises need so much more. They need management interfaces, monitoring, security features, multi-tenancy, SLAs, support contracts. Think about it. If you're a bank running customer service chatbots, you can't just grab code from GitHub and hope for the best.
But couldn't the cloud providers just build these enterprise features themselves?
They could, and they probably will to some extent. But Inferact has a few advantages. First, they have the core team that built vLLM. That institutional knowledge is invaluable. Second, they can move faster than the big clouds. AWS and Google have to worry about integrating with their existing services, maintaining backward compatibility, dealing with internal politics. Inferact can focus solely on making inference blazingly fast.
Plus, there's the multi-cloud angle. If you're using Inferact, you're not locked into AWS or Google's ecosystem.
Exactly, and that's huge for enterprises. I know several large companies that have explicit multi-cloud strategies. They want to avoid vendor lock-in, negotiate better prices, and have disaster recovery options. An inference layer that works across clouds, that's incredibly valuable.
Let's talk about the competitive landscape. It's not just the clouds. There are other startups in this space. Replicate, Modal, Banana.
Right, but most of those are focusing on the developer experience layer, making it easy to deploy models. Inferact is going deeper into the infrastructure stack. They're not competing with Replicate. They're potentially the engine that Replicate could use under the hood. It's like the difference between Heroku and the Linux kernel. Both important, but operating at very different layers.
What about the reported $800 million valuation? That seems astronomical for a company commercializing open source infrastructure.
Yeah, we should emphasize that valuation is unverified. But if true, it reflects just how critical inference optimization has become. Consider this. OpenAI is reportedly spending $700,000 per day just on inference compute. If you can cut that by even 30%, you're saving them $75 million a year. Multiply that across all the companies deploying LLMs, and suddenly an $800 million valuation doesn't seem so crazy.
But can they maintain their technical edge? What happens when NVIDIA releases new hardware optimized for transformer inference?
That's the key question. Stick around. We'll dive into what this means for your infrastructure decisions and how to think about the build versus buy trade-offs when it comes to AI inference optimization. All right,
Let's get practical. If you're running AI workloads in production, what does Inferact's emergence mean for your infrastructure strategy? First thing, you need to audit your current GPU inference costs. I mean, really dig into the numbers. How much are you spending per request? What's your GPU utilization? Are you leaving performance on the table?
How would someone even measure that? Most teams I know just look at their cloud bill and wince.
Start with basic metrics. Log your request patterns. What's the distribution of input lengths, output lengths, concurrent users? Then benchmark your current setup. Tools like Apache JMeter or even simple Python scripts can help you measure throughput and latency. The key insight is that inference optimization isn't one size fits all. A chatbot with short interactions has very different needs than a code generation tool producing thousands of tokens.
So when should teams consider something like Inferact versus just using their cloud provider's managed service?
Great question. Here's my framework. If you're spending less than $10,000 per month on inference and your use case is pretty standard, stick with managed services. The operational overhead isn't worth it. But if you're spending six figures monthly, or if you have specific performance requirements like sub 100 millisecond latency or need to handle massive concurrent users, then specialized inference infrastructure starts making sense.
What about teams that want to experiment with vLLM before committing to a commercial solution?
Absolutely do that. The open source vLLM is production ready for many use cases. Start by containerizing it, deploy it on your Kubernetes cluster, and run some benchmarks. Compare it against whatever you're using now. Just be prepared for the operational complexity. You'll need to handle model loading, request queuing, error handling, monitoring, scaling, all the stuff that Inferact presumably handles for you.
Speaking of monitoring, what metrics should teams track for inference workloads?
Beyond the obvious ones like requests per second and latency percentiles, track your token generation rate, tokens per second per GPU. Monitor your batch sizes. Are you efficiently packing requests? Track your queue depths. Are requests backing up? And crucially, monitor your cost per 1,000 tokens. That's the metric that directly impacts your bottom line. I've seen teams cut their costs by 60% just by optimizing batch sizes and request routing.
What about the broader implications? If inference becomes dramatically cheaper, how does that change the AI application landscape?
This is where it gets really interesting. Right now, lots of AI applications are economically marginal. That chatbot might provide value, but if it costs $2 per conversation and you're charging $5 per month, the math doesn't work. But cut those inference costs by 70%, and suddenly whole new categories of applications become viable. We could see AI integrated into many more consumer applications, real-time AI in gaming, personalized education tools.
It's like how cheaper bandwidth enabled streaming video. The infrastructure improvement unlocks new use cases.
Perfect analogy. And just like with bandwidth, we'll probably see a Jevons paradox effect. As inference gets cheaper, we'll use dramatically more of it. Instead of carefully crafting prompts to minimize token usage, developers will build more conversational, iterative interfaces. Instead of caching responses aggressively, applications will generate fresh content for each user.
But doesn't this create new challenges? If everyone's inference costs drop, won't the competitive advantage disappear?
That's the thing about infrastructure improvements. They raise the bar for everyone. Your competitors get the same benefits, so you need to innovate on top of the new baseline. The winners will be companies that use cheaper inference to enable fundamentally new experiences, not just make existing ones slightly cheaper.
Any predictions for where this market goes?
I think we'll see rapid consolidation. There are too many inference optimization startups for the market to support. The winners will be those who can build genuine network effects, maybe through model caching across customers or by becoming the standard that other tools integrate with. I also expect the open source versus commercial tension to intensify. If Inferact is too aggressive in commercializing vLLM, we might see a community fork.
That would fragment the ecosystem.
It would, but it's happened before. Look at Docker and Podman, or Elasticsearch and OpenSearch. The key for Inferact is to keep the community happy while still building a viable business. That means contributing improvements back to open source, being transparent about the roadmap, and making sure the open source version remains genuinely useful.
So, for our listeners, platform engineers and architects thinking about AI infrastructure, what's the key takeaway?
Don't ignore inference optimization. It's not sexy like training massive models, but it's what determines whether your AI applications are economically viable. Start benchmarking your current setup, experiment with tools like vLLM, and keep a close eye on this space. The companies that figure out efficient inference will have a massive advantage. And remember, in the gold rush, the people selling shovels often do better than the miners. Inference infrastructure might just be the shovels of the AI era. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development at Anthropic. Their Claude code tool is completely reshaping how they build software internally. According to Wired, this AI coding assistant has become so popular in Silicon Valley that it's actually changing Anthropic's entire business model.
Wait, so they're using their own AI to build more AI? That's pretty meta. How exactly is it changing their business?
Well, the article highlights how Claude Code has dramatically accelerated their development cycles. Engineers are reporting 2 to 3x productivity gains, and it's not just for simple tasks. They're using it for complex system architecture and debugging.
That's incredible. If they're seeing those kinds of gains internally, imagine what it means for the broader software industry.
Speaking of industry shifts, Google DeepMind CEO Demis Hassabis just expressed surprise about OpenAI's decision to introduce ads into ChatGPT. TechCrunch reports he's worried about user trust.
Ads in ChatGPT? That seems like it could really degrade the experience. What's Hassabis' specific concern?
He believes it could compromise the assistant experience and erode user trust. He pointed out that once you introduce advertising incentives, it becomes harder to maintain neutrality in AI responses.
That's a valid point. We've seen how ads have shaped other platforms, usually not for the better.
On the technical side, OpenAI just published an incredible deep dive on how they scaled PostgreSQL to support 800 million ChatGPT users. The engineering challenges were massive.
PostgreSQL for 800 million users? That's pushing it to the absolute limit. What optimizations did they implement?
They had to completely rethink their single primary architecture. The article details how they achieved millions of queries per second through custom sharding strategies and connection pooling optimizations. It's a masterclass in database scaling.
It's amazing they're sharing these technical details publicly. That's going to help so many teams facing similar scaling challenges.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.